Now, this part is my explanation about the reaction on the cathode. Remember, in electrolysis, we have a battery. The negative electrode is called cathode, and the positive electrode is called anode. Right? And we have two inert electrodes, platinum and graphite. Other than those two, non-inert electrode, which means they can react. They might react. Yes. Then we continue on the same example. We use example 1. The electrolyte is dilute sodium chloride, NaCl. The anode and cathode are platinum. We did the reaction on the anode. Now we learn what are the reaction on the cathode. On the cathode, there will be reduction because the cathode is connected to the negative side of a battery, and you have a lot of electron being pumped by the battery to that cathode. And that electron will reduce the substances that is in contact with cathode. We have five substances that can be reduced. 3 of them is very unlikely. 3 of them are very unlikely to be reduced. I explain these 3 first. They are platinum. Number 1, platinum. First of all, platinum is a metal. Metal cannot be reduced, right? Have you seen any negatively charged metal? No. Yeah, it's very difficult to get reduced. So the cathode itself will not be reduced. This reaction will not work. The other two substances, OH minus from water, right? So remember, this is dilute sodium chloride, means it contains water, and there are OH minus in water. OH minus is already negatively charged, it's a negative ion. It's very difficult for you to reduce it even further to OH2 minus. It's almost impossible. So it's not reacting. The same thing happens to Cl minus. They are negative ion and they are non-metals. Non-metals negative ion are difficult to accept electron. Now, so this tree is out because it's a metal, and these are the 2 negative ions. So for the next example, for example 2, 3, and 4 that we are going to learn in this video, we will cross them out, right? What type of substance is more likely to get reduced? Sorry, they are cations. They are positively charged, so it's easy for them. They're more likely to get reduced, and we have 2 of them. H plus from water, yeah, and Na plus from NaCl. We must choose one of them. Very simple. On cathode, we have only one rule on which one should we choose for reduction. We choose the one that is lower in reactivity series. In this case is H plus. Yeah, Na plus is very high. The reason for that, sodium is reactive. Sodium is reactive. Is less likely for you to produce something that is reactive. H2 is less reactive than sodium, so it's more likely for you to produce H2. Yeah. So remember, we have 5. 3 of them are very, very unlikely. We just cross them out, these 3: platinum, OH minus, and Cl minus. We don't need to consider them. We have 2, H plus and Na plus. We choose H plus because it's lower in reactivity series, produce a more stable product. Yeah. That is example 1. We have dilute NaCl using platinum electrodes. Next, example 2. Example 2 is similar. We have concentrated sodium chloride, yeah, with platinum electrodes. Then which one will we choose? We cross out 3 substances that are very unlikely to get reduced: platinum, OH minus, and Cl minus. Platinum because it's a metal. OH minus because OH minus and Cl minus because they are negative ion. They are already negative ions, right? It's difficult for them to turn into even more negative. You have H plus and Na plus. Which one you choose? H plus, which will turn into H2 because H2 is lower in reactivity series. This is a more stable product. So when you choose 2 reactions, there are two ways you can decide which one is more likely to happen. Number 1, if you have less stable reactants, then it's more likely to happen. Or you produce a more stable product, then it's more likely to happen. So remember, you choose the one that has less stable reactants or a more stable product. In this case, H2 is a more stable product because it's lower in reactivity series. Then that is example 2. So we choose the same reaction, which is H2. How about example 3? Example 3 is molten sodium chloride using platinum electrodes. As usual, we cross out the 3 substances that is very unlikely to react. Platinum because it's a metal, OH minus and Cl minus because they are negative ions. So we cross them out. Now we have H plus and Na plus. Which one will we choose? Shall we choose H2? Because it's more stable. In this case, no. Don't choose this. Yeah, don't choose. Why? Because the H plus here simply does not exist. There is no H plus because this question is talking about molten sodium chloride, Na plus, NaCl, molten without any water involved. Yeah. Yeah, the water does not exist. Then left with this reaction, Na plus turn into sodium. So I must pick that one. That is example 3. Now back to example 4. Back to example 4, we cross out these three: platinum, OH minus, and Cl minus, because they are metal and negative ions. Concentrated sodium chloride. Yeah. This time the anode is zinc, but the anode won't affect our reaction because we are analyzing reaction on cathode. Yeah. Concentrated sodium chloride. Does H plus exist? Yes. That means in this case we just choose H plus, which will turn into H2 because it's lower in reactivity series. And don't choose the Na. Don't choose the sodium. So that's it. We do the 4 examples already. We quickly revise the way we choose the reaction on cathode. On cathode is connected to the negative side of the battery, which means you have a lot of electrons and you won't have oxidation reaction there. You will have reduction because you have a lot of electron. And the reaction that are unlikely to work are the reaction metals are unlikely to get reduced. OH minus and Cl minus, which are negative ions, they are also less likely to get reduced. The one that is more likely to get reduced is the cations. And which cation must we choose? If we have 2 of them or 3 of them, we choose the one that is lower in reactivity series because they produce more stable product. That is, in example 1, we choose H plus, which will produce H2 because it's lower than sodium. In example 2 also, because we have dilute sodium chloride, we have a lot of water, which means we have H plus. We choose H2 also and don't choose Na because Na is higher in reactivity series. And in example 3, we choose Na because H plus simply does not exist. You cannot choose a reaction that doesn't exist. So you just choose sodium. Yeah, Na plus electron turn into Na. How about example 4? We must choose H2 again because H plus exists because we have concentrated sodium chloride. So that's the second part of this video. We learn how to choose the reaction on cathode. So on the next part, we are going to learn about how to combine these 2 half equations, the oxidation half equation and the reduction half equation, to produce ionic equation. Yeah, the overall reaction of the electrolysis. Yeah, please watch the next part of the video. Thanks.